As weapon systems and avionics become more sophisticated, the need to maintain current technology standards in the repair shop is essential. The complex electronic circuitry, such as we have today, requires a new level of accuracy and precision in the handling of micro-miniature, surface-mounted, integrated circuits and other electronic components. The tools we use for repairing these printed circuit boards must match the accuracy and precision of those used in the manufacture of these devices. Accordingly, the Sniper 2 split vision rework system was developed to provide a fast and accurate method of circuit board rework for surface-mounted devices using practices concurrent with today's manufacturing technology. This program provides a basic orientation to the Sniper 2 rework station to help you, the repair technician, get up to speed in the repair and rework of these highly sophisticated circuit cards.
Safety is our greatest concern in the 2M program. Refer to your safety manual for all hazmat concerns. Always use your safety goggles. Practice all ESD safe procedures. Caution when working around heating elements. By becoming proficient in the operation of the Sniper 2, you will have attained a marketable skill desirable in both the military and the private sector, in an area of technology that is the forefront of printed circuit board industry. The terminology you will learn and the various aspects of the machine are both current and common to the industry, with applications ranging from telecommunications to network infrastructure to R&D prototyping for newly advancing technologies, as well as many others. The purpose of the Sniper 2 is to provide the technician with an easy-to-use machine platform by which surface mount devices, or SMDs, can be removed and replaced on a printed circuit board substrate with the maximum of safety for both the substrate and integrated circuit, duplicating the original production process as closely as possible, thereby establishing a rework environment that is similar in both quality and safety for both the printed circuit board and the integrated circuit. The Sniper 2 rework station will allow the technician to both remove and replace surface mount devices on virtually any substrate. Examples of components include QFP, PLCC, BGA, plastic connectors and sockets, transformers. For all intents and purposes, any device that is attached to the surface of the printed circuit board with solder. The Sniper 2 features forced air convection technology, which can very closely mimic or duplicate the original production reflow process. It has a 1200 watt heater for the top side airflow and a 600 watt heater for the bottom side, or preheat side of the printed circuit board. Airflow is fixed at 12.5 cubic feet per minute. This very gentle airflow assures even heating around the integrated circuit and substrate, and due to the limited turbulence of that low air velocity, will not disturb adjacent components during the rework process. Also featured on this machine is the automatic removal of the component at reflow, accomplished by the vacuum pickup, or VPU. The VPU attaches to the component by vacuum cup and applies a slight positive lift to the component during the heating cycle. When all solder connections to the IC have reached reflow temperature, the component is automatically lifted from the printed circuit board. Automatic removal at reflow assures maximum safety for the printed circuit board and IC, and also helps to determine the requirements for the placement reflow cycle. Controllers for both the bottom and top heaters allow storage of bottom heat profiles and top heat patterns for easy recall when a particular project might be returned for rework later. The topside heater can be precisely controlled so that optimal results are repeatable. The Sniper 2 also includes split vision optics using a dichroic alignment beam image splitter, or DABIS, which allows for simultaneous viewing of both the component leads and the printed circuit board lands on the supplied 13-inch monitor. The board holder micrometer adjustments for the X and Y axis and a rotating platen for the theta correction allows for precise alignment and placement of various integrated circuits with an accuracy of 1/1000th of an inch, eliminating the tedious and time-consuming process of manual placement and alignment of the integrated circuit to the printed circuit board substrate. The optical system is robust and simple, eliminating the need for frequent calibration and adjustment. The Sniper 2 is built on a sturdy chassis and is designed for years of use under even the most demanding conditions. The following is an overview of the switches available to the operator. Main power switch, reflow continuous switch, which is only used for the foot pedal operating machines. Reflow control switch, bottom side controller switch, component vacuum removal, table lock, alignment placement switch, component vacuum, placement, reflow Z-axis switch, board holder theta adjustment knob. The following are machine components that the operator should familiarize themselves with: the camera, camera hood, placement assembly, reflow head, vacuum pickup device, focus nozzles, preheat bottom side head, and emergency shutoff switch. Production processes for printed circuit boards include screen printing of solder paste to the printed circuit board substrate, followed by component placement by either hand or machine. The loaded printed circuit board is moved through an oven to heat the solder and substrate to an acceptable temperature that creates a good solder joint between the integrated circuit and the pad areas of the printed circuit board. In the heating process, the printed circuit board is subjected to intervals of heating at consecutively rising temperatures to induce the printed circuit board temperature to rise toward the solder melting point, 361 degrees Fahrenheit. The rate at which the temperature rises at the soldering points is known as the ramp rate, usually expressed as degrees per second. Example, 10 degrees Fahrenheit per second. The printed circuit board will not always keep up with the rising temperatures of the air in the sequential zones, so it may be required to hold the printed circuit board in the higher air temperatures to allow it to catch up in temperature. This holding period is known as a soak. A typical industry process will incorporate a ramp to a preheat temperature with a short soak to follow. Then the printed circuit board is again ramped up to the flux activation temperature and then soaked again for a short period of time. After flux activation, the printed circuit board is then ramped up to the reflow temperature and held soaked for a short period of time to effect a correct solder joint, and then cooled in what could be considered a negative ramp. As shown in the example, the Sniper 2 can duplicate an industry standard reflow profile, providing repeatable quality results for your repair processes. The Sniper reflow controller has a separate on-off switch located just below the controller that will shut it off so that the bottom side heater can be used singularly. In all cases, this switch is to remain in the on position. For functions of the Sniper 2 reflow controller, the following terminology will be adhered to. A single set of instructions programmed into the reflow controller shall be known as a pattern. The controller can store 16 different patterns. Each pattern can consist of as many as 16 segments. A segment is defined as a set temperature goal and a time to reach that temperature goal. To define a segment, the controller will require an input of a temperature, or LEV, and a time, a TI. Assume the operator has decided to create and store a new pattern. Press PTN end once, then use up or down arrows to select pattern 16. Press set. Press set 2 times to see level 1. This is the temperature setting for segment zone 1. Use the up or down arrows to arrive at the desired temperature, 200 degrees. Press set. You will now see TIM 1. Use the up or down arrows to arrive at the desired time to reach the temperature from level 1, 30 seconds. Press set. See level 2. This is the temperature setting for zone 2. In this example, we are going to use zone 2 as a soak zone. Use the up or down arrows to set the temperature at 200 degrees. Press set. See TIM2. Use the up or down arrow to select the amount of time to soak, 30 seconds. Press set. See Level 3. Temperature setting for Zone 3. Use up or down arrows to set 300 degrees. Press Set. See TIM 3. Use up or down arrows to select the time to reach 300 degrees. Press Set. See Level 4. Temperature setting for Zone 4. Use the up or down arrows to reach 300 degrees. Press Set. See TIM 4. Use up or down arrows to select the amount of time to soak, 30 seconds. Press Set. See Level 5. Temperature setting for Zone 5. Use the up or down arrows to reach 500 degrees. Press Set. See TIM 5. Use up or down arrows to select the amount of time to reach 500 degrees, 1 minute and 30 seconds. Press Set. See Level 6. Temperature setting for Zone 6. Use the up or down arrows to reach 500 degrees. Press Set. See TIM 6. Use the up or down arrows to select the amount of time to soak, 1 minute and 30 seconds. Press Set. Press Reset. This completes the creation of a basic profile. To use this profile, press Run. A summary of this example profile is written like this. Segment 1, ramp to 200 degrees in 30 seconds. Segment 2, soak at 200 degrees for 30 seconds. Segment 3, ramp to 300 degrees for 30 seconds. Segment 4, soak at 300 degrees for 30 seconds. Segment 5, ramp to 500 degrees in 1 minute and 30 seconds. And Segment 6, soak at 500 degrees for 1 minute and 30 seconds. Why are there different patterns? The energy required to heat the solder is carried in the airflow. When the airflow strikes the package or package leach, the energy is given up in the form of heat, and the component, printed circuit board temperature, rises. In a leaded package such as a QFP or PLCC, the heat is transferred to the soldering area very quickly, as the leads are directly in the airflow and can see the heat very quickly. In a ball grid array, or Micro BGA, the soldering points are beneath the integrated circuit and do not directly see the heat energy. The heat to melt the solder must be transferred directly through the component itself. The component itself is made up of different materials, from the plastic of the package itself to the silicone die contained within, and the wire bonding materials in connection within the integrated circuit. Each of these dissimilar materials has a different coefficient of thermal expansion and must be allowed to absorb heat and expand as evenly as possible in order not to damage the integrated circuit during the rework process due to thermal expansion. The preheat controller has two user-determined settings that can be altered. One is the set temperature for the airflow. The other is the amount of time desired to reach the set temperature. For the purpose of the Sniper 2 preheater, the combination of these two factors constitutes a profile. The user can store 4 independent profiles in the controller itself, and recall any of the stored profiles to use for the current project before beginning the heat cycle. Why should we change the profile and ramp rate? Bottom side heater profile is determined by relative board mass and component density. Another factor is the actual board area. A small, thin printed circuit board will come to temperature relatively quickly, whereas a small, dense board will be slower to absorb the heat energy and will come to temperature at a slower rate. Higher mass, larger printed circuit boards will require a slower ramp rate to temperature in order to minimize warpage of the substrate. Default settings for the controller are such that a higher profile number is equal to a slower rate of ramp. The controller will store 4 different profiles, each profile consisting of both a set temperature and a time to reach that temperature. Both of these settings can be modified and stored by the technician. Default ramp times for the bottom controller are as follows. Profile 1. The controller will ramp temperature very quickly. Profile 2. Ramp time 1 minute. Profile 3. Ramp time 2 minutes. And Profile 4. Ramp time 5 minutes. For the purpose of the controller display, Prof means profile. SV1, 2, 3, and 4 mean temperature, set values. SV is followed by the number of the profile being used. For example, SV3 means set value for profile number 3. TI means time. RAP means ramp. To change the profile for the bottom heater, press the Set key once. Use the up or down arrow keys to select the desired profile number, then press Set 2 times. The display will return to the default display, which is the current air temperature over the word Stop. To change the set value or temperature for a given profile, press and hold the Set key for 3 seconds. The display will read SV1 if in profile 1, or SV2 if in profile 2, etc. Use the up or down arrows to reach the desired set value or temperature. Press and hold the Set key for 3 seconds to return to the default display. When choosing the proper focus nozzle, select a nozzle that is slightly larger than the component. It is acceptable to use an oversized nozzle. It is not acceptable to use a nozzle that is too small. Once you have selected the proper nozzle, insert the nozzle upward into the reflow head, flange up, and twist so that the nozzle is squared to the operator. The VPU, or vacuum pickup, uses a high-temperature silicone vacuum cup. Select a vacuum cup that is not larger than the component body. 3 sizes are available. The vacuum cup will survive approximately 70 to 100 reflow cycles. To change the vacuum cup, wait for the reflow head to cool, then remove the nozzle from the reflow head. Depress the VPU and gently pull downward on the old vacuum cup to remove it. Push the new vacuum cup onto the VPU barb. Select a placement barb based on the component size. If the component is either larger or heavier, a larger size barb should be selected. To change the placement barb, extend the placement assembly using the alignment placement switch located on the right-hand side of the machine. Unscrew the barb. Screw the selected barb into the placement assembly. Hand tighten only. Retract the placement assembly using the alignment placement switch. We have talked about many different parts of the repair. Now we'll do a complete repair process from start to finish. Secure the work into the board holder. Use the middle slot or the top slot for thicker boards. Adjust placement height by lowering the board holder to the lowest position. Then move placement alignment switch to placement position. Then move the board holder underneath the placement barb and raise the board holder height to meet the top of the component. To a point where the barb just makes contact with the component. Retract the placement barb by moving alignment placement switch to the alignment position. Raise the reflow head by moving the reflow Z switch to the up position. Select the proper nozzle for the component and insert it into the nozzle block assembly. Move your work beneath the nozzle and move the reflow Z switch to the down position using the micrometer at the rear of the reflow head to adjust working height to 1/8 of an inch to 1/4 of an inch above the integrated circuit to be worked on. Raise the reflow head by moving reflow Z switch to the up position. Apply paste flux to the leads. Move your work beneath the reflow head and put the reflow Z switch to the down position, centering the component beneath the nozzle. activate the component vacuum and depress the vacuum pickup to contact the component. Choose the pattern to match required component removal profile. Press PTN End button once. Use the up and down arrows to select the desired pattern. Press Set. Press the Run Hold button. The component will be lifted from the printed circuit board at the proper time. The machine will cool at the completion of the profile. Move the reflow Z switch to the up position and slide the board holder out from underneath the reflow nozzle. Prepare the site by cleaning flux residues and removing all the solder from the pads using solder wick or braid. Use a soldering iron to add equal solder to each pad. Clean the site again with the pad prep pen or other flux remover. Dispense a small amount of flux paste to the pad area and spread evenly with a brush. Move the alignment placement switch to the placement position. Activate the component vacuum by moving component vacuum switch to on. Present the component to the placement bar, being careful to check pin 1 orientation to the board. Move the alignment placement switch to alignment position. The component is now viewed on the monitor. Move your work beneath the placement head and view the gross alignment on the monitor. Use the camera adjustments to adjust light, zoom, and focus for best component viewing. Lock the table down by moving the table lock to the up position. Use the micrometers attached to the board holder to finalize X and Y axis adjustments. If the theta correction is required, use the round theta adjustment knob located at the front left of the machine until the correction is satisfactory. Move the alignment placement switch to the placement position. After the component has been placed on the board, turn off the component vacuum by moving switch to off position. Move the alignment placement switch to the alignment position. Release the table lock. Move the board holder from the placement area to beneath the reflow head, being careful not to bump the board holder on the bottom heater. Move the reflow Z switch to the down position and center the work beneath the nozzle. Choose the pattern to match the required component placement profile. Press the PTN End button once. Use the up and down arrows to select the desired pattern. Then press Set. Press the Run Hold. When the reflow profile is complete, the machine will cool down, the controller will show End on the display. Move the reflow Z switch to the up position. Allow the work to cool before removing from the board holder. This orientation video has presented you with the tools necessary to operate the Sniper 2 safely and efficiently. If you have any operational or process questions, the 24-hour customer service telephone numbers are located on the right side of your machine.